Hi there. In my attempt to automate Thomas the tank engine, I need to automate the points. So I've done that in 3 different ways. The first one I tried was this. It uses a typical 9-gram servo motor. It has a wire coming across from the top of the servo, a bit of paper clip, and a wire coming through underneath the points. That then goes to this little tab here, which I've drilled a hole through and put the wire through. Can't remember why that solder's there. I can't remember if it's a joint or anything. I certainly don't think it's an end stop. So if we have a look at that, something else that's of importance is these points are really difficult to automate. They've got masses of tolerance in them. Whether that's designed in or just accident, I don't know. So I've put a piece of blue plastic round that end of the point bit that moves, and also if I switch it on and try it, then we can see how the servo, which took quite a bit of setting up to get the right position, goes across, moves the points and then comes back again. This is so that if a train comes along, it can move the points on its own without moving the servo. So that's using a servo very crudely attached to the points with this little bit bent of plastic, and I've just drilled through the top of the servo to put the paper clip onto it. Very crude, big, bumbly, so I'm not as happy with it. This one then has a hidden mechanism. Hopefully this one will play. Oops, wrong one. Which one do I want? There we go. That's that one. It's on my controller here. That's picking up the infrared. So when I press the button, it moves across. It has nothing visible, because what I've done is to take a point motor, a Hornby I think it is, connect that underneath, and what I've done with that is on the end of it I've just put a paper clip across to the bottom of the moving part, which in this case is metal, so I've just soldered onto that, come across, and so that this solenoid, well, these 2 solenoids, one moves it one way and the other moves it back again, so they move independently. That needs 3 wires, a common wire, and then a wire to move one solenoid and a wire to move the other solenoid. That though needs more complicated electronics, so what I have here is a board I've built, which, if we can see it, so this is very crude, built on Veriboard, uses surface mounted transistors, FET transistors, but they're on the top. The idea of this board is then it just sends a quick pulse to the solenoid or the coil of wire, and that quick pulse moves the coil of wire and moves it in one direction, then back in the other. So that's my second version. The point motors themselves, I have one here. It's got its wire wrapped around it. If I unwind it, oopsie, got it wrong. Come on. Oops, it's all falling apart as well. So what I have is this bit comes on, it actually fits into that end there, and then we have the solenoid itself, which is easy enough to take out. There should be a piece on the bottom, of course, which would hold the solenoid in place. We can see then that the two solenoids are there and there. This piece normally wouldn't be able to fall out, but once the coils have fallen out, this just goes into the metal piece which is in the coils. Wish I'd never started this. What's happened? Where's my metal piece? There's my metal piece. There's my coil. There's my piece of wire. Just fits into that hole there. And as long as that piece of metal, is that an armature, is inside, then the wire can't come off, and as long as the two solenoids are connected in correctly, then that can't come apart. So that's I think that's a Hornby unit, but they're quite expensive, couple of, well no, about £8 I think they are each, and if you've got a few points then it really adds up. So it seems simple enough. 2 coils of wire, surely I can do some coils of wire. I can find coils of wire on lots of things. There's stepper motor device out of a, or I don't know if it is a stepper motor, probably not. It's out of a disk drive anyway, a floppy disk drive. There's another one here, just a coil of wire that's come out of a timer, washing machine timer. But the beauty is it has all this wire wrapped round. It's got 10 kilo ohms of wire because it's designed for a mains application. My coils, then I've done underneath here, I've wound these 2 wires onto 2 coils on pieces of 3mm, I think it's welding rod, beautiful stuff, lots of uses. I've soldered washers on the ends to make it into a coil, and then I've soldered them on. Now this is a bit like a, I forgot what it's called, is it TO Mix, a Japanese firm's device where they have the 2 coils but they're connected together. I think they've connected them in series, but this is only, these 2 are connected in parallel. The idea is that this is a magnet in the middle. This side of the magnet's a south, this side of the magnet's a north, and so this will move across from one place to the other, and as it goes across, I've just screwed it onto the piece of plastic so that as it goes it turns the moving part here, moving that. I've put epoxy on to try and make it a better fix. I should have used plastic like on the first one, but don't know why I haven't, to try and overcome all the looseness in this pivot point. So if we try this one, I haven't actually connected it up to my microcontroller yet, but if I take the power, I can hopefully touch that. Wrong way. Oh, it's catching, I think, on the table, so it won't work as I would like it to. So if I move it there, nothing. There flies across. There flies back again. Hopefully we can see, if I zoom in a bit and move it a bit this way, we can see the magnet. So it is pushed and pulled. Pushed by this coil there, pulled by this coil, and therefore it moves across. Turn it over. If I can get the contacts. And then it operates in the opposite way because I've altered the current through the coils. I've connected the coils in parallel here. I did have them in series, but it took 12 volts to operate it. So by putting them in parallel, I can get away with 6 volts. I haven't actually measured the current yet that it takes, but it doesn't seem to be excessive. So let's see if we can get it to move across. Let's zoom out there. So if I just touch them together, wrong way, then it moves across backwards and forwards. So that's point motors. I've done a lot of examples. I've tried a lot. I've tried with brass tubes. So this has got 2 coils on it, a brass tube, 2 coils. The idea was to be like the Hornby with a armature in the middle which would come out the end, but I didn't have too much success with that. Many years ago, as a teacher, I ended up teaching a pupil electronics, or supposed to be teaching him electronics, and he built his own controller board. That's this one, but that uses a capacitor, which is what most point motors seem to use. Charge up a capacitor, it then has enough power, if it's discharged quickly, to move the point motor. This point motor is very interesting because it actually has a switch on it. So as it goes across, this switch at the front moves from one side to the other and back again. So thus you could use signals to show red or whatever with it. It takes a lot of power though to move it, and it's very big and bumbly compared to the track, so I couldn't hide it very easily. It uses this CMOS chip to produce the pulse, which goes to either of these 2 Darlington transistors, which discharges the capacitor through one of the coils, thus moving it from one side to the other. Unfortunately, it's not a very beautiful example. I think he must have had a very poor teacher to end up with that. But it does work, and I don't know what grade he got for it, but it was back in the 2710-97. Wow, that makes it what, 23-year-old. That 15-year-old student or 16-year-old then will be how old now? 39. How quickly time goes. So that's point motors. Don't think I've much more to say. I think the idea of building my own is quite useful. Certainly need to look at modifying the track so that it actually doesn't move too much in the pivot point. Right then, point motors, or of course I haven't mentioned in America, turnouts. Yeah. So, bye now. Bye.